Hello and welcome to this episode of the Clean Sailors podcast. I'm really looking forward to this conversation with two absolute experts on today's topic. Two people I greatly respect, admire, and have recently spent time sailing with mid-Atlantic in the Azores, collecting and monitoring samples on this very topic, microplastics. Joining us is Dr. Christopher Pham, a member of various international expert groups on this topic, a research associate at the Okinawa Research Centre of the University of the Azores, specialising in marine litter, plastic pollution, deep sea ecosystems, and how us humans are impacting our oceans. Also joining us is Dr. Roman Lehner, a keen sailor and scientific project leader and co-founder of Sail and Explore Association. His specialism is microplastics and the even smaller counterparts, nanoplastics. Roman is concerned with the impact of microplastics on the human body and has instigated the world-first research into just how these tiny pieces of plastic may be affecting the functioning and interactions of our very cells. So we are in great company on this topic, and thank you both for joining. What are microplastics? Chris?
Okay, so microplastics are actually plastic particles that are smaller than 5 millimeters. So within that smaller fraction, we have plastic particles that is below 1 millimeter, which we call really small microplastic, which you cannot see with the naked eye. And then you have particles between 1 and 5, which are called larger microplastics, which you can see. And microplastics can come from two different sources. You have the secondary microplastics, which come from the fragmentation of larger items, larger, big items, or even like ropes that are degrading. And then you have the primary microplastics, which are actually manufactured as small particles. For example, those microbeads that you have in cosmetic products, but also something that we don't always remember, which is the fibers from the clothing. So there's really a distinction between the primary microplastic and the secondary microplastics.
So primary are manufactured to be small on purpose. Like you said, I guess clothing fibers, microfibers are intentionally made that way. And then secondary is obviously, like you said, being broken down from bigger pieces of plastic over time, ultimately creating smaller and smaller pieces as they get exposed to UV, salt water, etc.
Exactly.
And then nanoplastics too, because that's obviously by definition even smaller. I mean, microplastics is almost capturing the process of plastic degrading over time, right? It's part of the middle of a sliding scale of plastic sizes.
Yeah, nanoplastic is even smaller than 1 micron, but I think our colleague Roman can describe what really are nanoplastic and what's the origin, what's the sources.
Because you can't see these with the naked eye, right?
No. Everything that is smaller than 1 millimeter, you cannot see with the naked eye. But the nanoplastic, something even harder to detect, I think. But Roman, please.
Yes. So, if you do talk about nanoplastics, we do talk about particles at the size of 10 to the power of -9. So it's really, really small. And as Chris was already pointing it out, something that is smaller or thinner than a human hair is not visible anymore with our naked eyes. So nanoplastics are super tiny little particles, and they do have the possibility to enter or to be taken up by any kind of like tissue, like fish tissue, human tissue, you name it. And due to this small size, we do talk about different problems that might occur if you do look on those nanoplastics compared to microplastics.
So why should we care? What is it about plastics and microplastics and them getting taken up by marine species and us humans, and also, I guess, plant species? Why should we care about it?
We should care really because it's something that is known to affect the biology and the physiology of different marine animals. And the problem here is really that there's a lot of microplastics, a lot of plastic generally in our ocean, and it's really becoming something regularly ingested by a lot of different animals, down from the small zooplankton up to the big, large whales. We're still trying to figure out really what is the impact at the population level. So we know that there is impacts at the individual level, but how does that affect population? How does that affect the reproductive success of different animals, and how does that change throughout the food chain? This is something that is quite still a topic of research, because as you probably know, the area of research in microplastic and plastic in general is quite recent. Probably 15 years ago, nobody would there was a few, really few research paper on that subject. This is something that is really has been kicked off for the past 10 years. So there's a lot of things to discover, but I think it's quite obvious that any synthetic polymer being ingested by animals has a negative impact. Not only just the physical aspect of having something inside your body that is not supposed to be there, it's also the fact that it's carrying a lot of different toxic compounds that might leach into the body. So it's really something that takes time to understand. We know that in lab studies, we know that we can really identify an effect. Now in the wild, it's something that we're still working on.
I think that's a really interesting point around, obviously they're not natural substances, right? So if you put plastic into an organic system as an inorganic substance, it's likely to have an impact, one would imagine. And we'll talk particularly about what that might do to our human bodies with Roman in a minute. But obviously plastics are quite absorptive materials as well. So over time, they're also picking up other things that they're getting exposed to. And that could be bacteria and different viruses, whether it's in the water or out of the water, as well as having their own toxic substances, chemicals from which they're created. So it seems like there's a lot of potential for them to be quite damaging.
Yeah, sometimes they are referred to as little sponges that is floating in the water. So as you said, they're just sucking up everything that is there and they're accumulating. So we've done that kind of analysis here in the Azores, looking at what sort of compounds we can find on those fragments that are really abundant here. And we're finding a lot of heavy metals, persistent organic pollutants of different kinds, and the concentration of those chemical compounds is really high. So as you can imagine, if a seabird ingests a few of those fragments, definitely has an effect on its health. So it's something really that we need to understand a bit more. But I think one thing I would like to stress is the fact that there's other stressors that are acting on those animals at the same time. That's the problem, and that's the challenge now that we're facing, is trying to understand how those different stressors like climate change, plastic pollution, fisheries, how all these are affecting those populations that are, already endangered. So that is the real challenge.
Separating out plastics from everything else, I guess, is your point, right? With so much going on.
Yeah, separating out, and then also trying to see how they are interacting. Plastic pollution on its own can probably be sort of dealt by the animals because they're, they can deal with sort of stress and, impacts. But when you have different stresses acting on different parts of the ecology or the life cycle of the animal, then it's getting a bit more complicated.
And obviously we spent time together, the three of us, sailing in the Azores and trawling for microplastics. What is it about these islands in particular as almost like a proxy for other regions of the sea? Because they're mid-Atlantic, they're exposed to extraordinary weather systems, also being caught between two major Atlantic gyres. So they are almost perfectly situated to receive a lot of inbound material from other parts of the world, and certainly from countries surrounding the Atlantic. What are kind of the things that you've been seeing and identifying in the water and with marine species, but also on the beaches?
Yeah, so like you're saying, we're really in the middle of the Atlantic Ocean. So we're actually really exposed to global pollution, because actually most of the items that we're finding in our waters are not coming from the islands, because as you can imagine, that small population. And even though if we emit, of course, I'm not saying that we're not emitting any plastics from the islands. There's still a lot of things to improve, but we have quite an efficient waste management system. So what we're seeing on our beaches is really things that are coming from far away. And we are really exposed to basically everything that is coming out from continental shelves, from big urban centers, that is, flowing out of the rivers, ending up in the ocean, being transported by these large current systems and accumulating really around our waters. And the fact that we are in the middle of the ocean also means that we're an important area for a lot of migratory animals. We're sort of the hotspot for all these different large migratory cetaceans, but also seabirds. And we are an important area for those animals. And our area coincides with also being a hotspot of plastic. So as you can imagine, it's quite a risky area for those animals to be now. And what we're seeing really is that this is not decreasing. We've been monitoring the waters, we've been monitoring beach litter, and we're not seeing any decrease in the quantities. We actually seems to see a little increase in the quantities and in the amount of fragments that are stranding on our beaches. I mean, last year we found, after a storm event, more than 15,000 fragments on a square meter of the beach. It was just, you couldn't see the sand anymore.
Wow.
And these, of course, are items that have been in the water for a long time. I mean, those fragmented pieces are probably pieces of plastic that entered the water, the ocean like 50 years ago, and then are continuing to be fragmented and standing on our beaches, going inside being ingested by seabirds, turtles. Yeah.
I think it's an incredibly poignant point, and appreciating that obviously the advent of plastic in, predominantly post-Second World War in the 50s was revolutionary, and obviously it made so many more things easier. It's light, it's durable, it's flexible, and obviously incredibly long lasting. And I appreciate that we're obviously now seeing so much of that collecting in our waters, but also that we're still producing and actually producing now more plastic than we've ever produced. And there isn't any kind of indication that that's going to slow. So dare I say, you'd imagine that you'd be seeing more over time plastic pollution, not just on the Azores, right? But certainly in many coastal communities, beaches, islands, or otherwise.
Yeah, although I think now, probably the past 5 years, there's been a real conscious awareness, I would say. I mean, a lot of effort has been done to sort of reduce the use of different plastic items. For example, the recent bans on single-use plastics. But this is going to take a lot of time to be noticed, in our data, because, as you said, there's been so much coming in, and the thing that they're fragmenting still. So the amounts are, we're still trying to understand actually how much is coming in. It's really hard it seems like an easy exercise to do, but there's still a lot of debate within the scientific community to really define how much there is, how much is entering, where is it going actually, because when we're looking at what is stranding our beaches and what is compared to what is coming in, there's something missing, and a lot of people are thinking that they actually ends up in the seafloor, but we don't know where, because of course it's not homogeneous. So there must be some hotspot on the seafloor that we're still trying to discover. But what I just want to say is that it seems to be that there is an effort in decreasing the amount of plastics coming in, but it will take a lot of time before this is going to be noticed, and before there's going to be a real effect on the fact that these animals will not be eating them anymore.
I think that's a really good point. At the moment, we obviously have so much plastic that we can see. Obviously, it gets washed up on our beaches, unfortunately. And the expedition that the three of us were on in the Azores, obviously trawling for surface water plastics, but presumably there's a ton of stuff, as many things in the ocean actually sink to the bottom. So understanding where plastic is settling on the deep seabed and what impact it's even having in those areas 11 kilometers down in the abyss, which we aren't as capable of accessing and researching so easily. So appreciating this as a all-encompassing and all kind of pervasive pollution problem, right? It can literally get everywhere and has got everywhere, also into our human systems. And I guess that is something that you've been working really hard on over the last years, Roman, is the impact of microplastics, in particular on human health. And I won't even try and explain the kind of work that you've done, because it's incredibly complicated and incredibly intelligent, but even to the point of recreating the human intestine cell structure in order to test the impact and uptake of microplastics into our human body. Why is that interesting? Why is it important? And what have you found so far?
Obviously the question always popped up what the plastic might have to do in regard of human health, like to us, health-wise, because it's a one thing that the plastic is in the environment, but we do know that all the aquatic organisms like fish and specifically mussel do take up those plastics, and we consume them. And so the question obviously popped up, okay, so what does it mean now for us? Is there any harm on us or not? And if so, what might it be? And the community just like 7 years ago started to try to focus on that. And I hopped on this topic at the very early stage. And I came up with the idea to set up this 3D human intestinal model, which should be kind of like a template model, allowing us to figure out what might be an adverse effect, or if plastic can maybe provoke an adverse effect, no matter what it is, if it's a toxicity effect or if it's a pro-inflammatory or inflammatory effect, for example.
So appreciating obviously trying to mimic the very cell structure of our intestines, and whether or not our own cells are actually absorbing microplastics. What did you find? And what was missing? What's the next step after that piece of research?
So first of all, I mean, there is already quite a lot of scientific proof that we do consume plastics, like microplastics. On one side, the main exposure route is, for example, via ingestion. So food uptake or intake, like seafood, but also like bottled water or tap water. There is proof that we can find some microplastics in bottled water, but also in tap water, or for example, in table salt or even in beer. And this most often has something to do with the production side of those products. And yeah, so we do know that we are exposed to this plastic and we ingest it and we even though inhale it. And so the point was, okay, we tried to figure out with this 3D model if there is any adverse effect. And what I did was I took different environmentally relevant materials, for example, like polyurethane, which is being used for all the running shoes, for the shoe soles, or polyamide, which is also called nylon, which is the main material for all the fishing nets, and polypropylene, which is a very common packaging plastic, as well as polyethylene. And the point was, so we exposed the model, or I exposed the model to those different microplastics, and I was aiming to see if there is, for example, any cytotoxic effect within time. So letting the material sitting on the cells for up to 2 days, and there was no cytotoxicity measurable or visible. And on top of that, I also checked if there might be a connection to a pro-inflammatory reaction. So can it be that a microplastic at a certain size is provoking a response of an immune cell on the material itself, expressing some molecules called cytokines, which are molecules like signaling molecules, which are involved in the inflammatory cascade. And we nicely could see that there is no effect, also there was no expression, no severe or statistically significant expression of those cytokines on the materials test. But it's also very important to mention here that the size that we used of those plastics compared to the size of the single cell was like 5, if not 10 times. Also the material was 5 times bigger than the size of the cell. And the point is, so if you want to or it's very important that the immune cells, for example, can properly interact with whatever is out there. So on one side, the purpose of the immune cells is to phagocytose, so to ingest a foreign compound or like a bacteria or a molecule, whatever it is, tries to digest it to figure out what it is and then to show all the other immune cells involved into the immune cascade to fight against this foreign material or particle or bacteria, whatever it is, organism. And so size is really an important thing here. And the size of the materials we have used was, as I mentioned before, was like 5 times bigger than the size of such a cell. Now you can maybe ask yourself, why did you do that? I mean, at that very moment when we did this study, that was 5 years ago, we did that in collaboration with a plastic producing company, and they were just able to produce those materials for us down to this certain size level. Nowadays, we improved the process. We were able, even though, to produce nanoplastics. The point will also be to use this model again and expose it and also to nanoplastics or just in general to smaller size microplastics, where we do know size-wise an uptake can happen via an immune cell, and to see what happens then. So
the next step is really to get even smaller pieces of plastic, which perhaps are tiny enough for our cells to interact with them, and then perhaps be better able to see whether or not either plastic inflames our cell structure or aggravates it somehow, or I guess the worst case would be in some ways absorbs it, and whether or not the toxins or otherwise that are in the plastic or on the plastic get taken up by our human system.
So the next step involves both. So on one side, the production of smaller size plastics down to nanoplastics, and we have already done that. We will soon publish this work until the end of the year, I hope. And on the other side, it also involves the improvement of the model, because you need to adapt the model, and it's just a model. That's the point. It's just mimicking an in vivo situation, but it's an in vitro situation, and you're still kind of like far away from the in vivo situation. So you need to improve the model. And specifically, if it's then about smaller sized plastics, you need to bring in more different cell types, because if you, from an anatomical point of view, if you do look on our intestinal tract, it's quite a complex organ. And trying to mimic that, it's not easy at all. And so therefore, it's always like, if you do see such data, like, or such experiments like the one that I have conducted right now with this model, you always need to digest it in a smooth way, like kind of like, you cannot just take that now for granted and say like, okay, look, they did this study. They didn't see any adverse effect and that's it. So, nothing will happen. That's not true. I mean, at the end of the day, the main aim from this study, for example, was to show like, what should we do or can we do if it's about human health? What's the right way to go for, like with those models? Because from an ethical point of view, there is no other way that, as we cannot just feed a person with plastic. It's just not possible. And so if you try to approach that, how do you want to do that? And you can also not just take an organ and inject or whatever plastic into an organ, because the organ needs to be alive. And so it's super complex. So this in vitro model is just like the first step of how to tackle those issues. Yeah. So it's both sides. So we have to improve those models and come up with better models, maybe also like some more specific models, because if you do look on different diseases like a bowel disease or so, you do know that you have a permanent inflammation state in the tissue. And you can mimic that. That's possible. Though such models do exist. And I mean, the other thing is then also to go maybe a step further and not just stick on the model of the intestinal model, but also like on lung models, as we do know that we do breathe in fibers, nylon fibers, etc., textile fibers, which are synthetic, so plastic-based. And this is really like the next direction.
This is almost just the beginning, right? So appreciating that, because as Chris mentioned, it's a relatively new area of science to be investigating. Whilst plastics have been around for decades and we've been using them for decades and they've been entering our environment for decades, we're still at early-ish stages of understanding just what impact they're having on certainly the human immune system and the functioning of our bodies. And to your point, I mean, you know, we've seen even in the last 12 to 18 months, 2 years, that plastic has been found pretty much everywhere. I mean, it's raining plastic, and it's been found in every major ice sheet on the planet and the top of Mount Everest. I mean, it really is everywhere and incredibly pervasive. And I guess the real question is, we almost have to, whether or not it has an impact on us, we almost have to clean up what is already out there, but also stop the flow of it in the first place. There's almost like a two-element approach to making sure that this issue gets solved in the future.
Of course, we have to reduce. We'll also have to clean up. I think this is going to be a real big challenge. I mean, the more we're studying, the more we're realizing that there is such a large emission of these particles that to be able to reduce is going to be a big challenge, and clean up is even bigger. But I'm still, sort of optimistic that things are going to, we're going to find a way to reduce the environmental footprint. I mean, in the sea, because on land, I think it's already too late. In the sea, there's probably ways to prevent the input of plastic to flow at that scale that we're seeing now. And there is people, really ingenious ideas of cleaning up. I mean, preventing more. Because I think once it's in the open ocean, once in the deep sea, it's impossible to go and clean up. I mean, just imagine an ROV mission in the high seas at 2,000 meters is almost 50,000 euros a day, So, and with a dive of 1 hour, you cannot clean nothing, basically. The challenges and the technical challenges and the financial challenges of cleaning up, once it's out there, it's just impossible. But we really have to focus on, preventing at the source, of course, with waste management, but also with systems in the rivers to prevent. And there's a lot of different technologies that are out there to prevent at least the larger items to go in the oceans.
I think it's a really important point, and obviously goes back to the relatively well-known fact that most of our pollution in the ocean comes from our life on land. And certainly when it comes to plastic pollution and packaging and otherwise, that's all belongs here at home and in our daily lives, which ultimately ends up in rivers and waterways and being washed out to sea. What is it that perhaps is that you're most concerned about? And I appreciate that plastic is a controversial topic, and I know that we need it, but what is it perhaps that you feel like we're not understanding or taking enough action on?
For me, it's clearly awareness, because if you do look on this plastic problem, then you can divide it into like the environmental problem that we have, like all the plastics ending up in our environment. And then on the other side, like the human health aspect, where you have to say, okay, sometimes you even though get exposed to plastics where you can like not choose, I mean, just because of the production side, the plastic is in the food or whatever. But when we do talk about the plastic that ends up in the environment, we solely talk about us and our behavior. And we can change that. And it's very simple, because if we do change that, then we don't have to talk anymore about like solutions of how to clean up the mess. Because I honestly, that's my personal opinion, I think we will not be able to do that. It's way too late for that. And it's not the right thing to do. It's good to do it if there is a way of maybe removing bigger sized stuff, but there is no chance anymore to clean up the ocean, okay, or the oceans. And so it's all about awareness. And I mean, we can really push that big time and teach our kids, like all the youngsters and in school, like how to behave and to really take care about that. And that's what it is. And with this, we have like, I think the biggest key in our hand to solve this problem.
And Chris, what about you? What do you feel is the thing that worries you the most, or the thing that you feel we're not truly understanding yet on a broad level?
There's different aspects. Like I said before, one thing that worries me a bit is really the interaction between all these different stresses. And because we're talking a lot about plastic, but there's pollution in general, you know. Marine pollution is a big subject. It's not only about plastics, and they all interact together. And we really don't understand in any field of research of, you know, anthropogenic impacts. We always look at things independently. And now we know that each of them have impact, but now we really need to know how things interact and how we should look at these as a global threats that needs to be tackled all together. So I think this is really what worries me, is that we probably understand that there's impacts about our activities in the oceans and on the planet in general. We already demonstrated there is impact, but now what is left to be discovered is probably even much worse. And that's what worries me. And what worries me, for example, is now we're talking about exploiting the deep sea minerals. Deep sea mining is something that is probably going to happen, even if we're trying to fight against it. I think it's quite obvious that in the near future it's going to happen. And we're still going to let it happen without good regulatory framework, without knowing what type of impacts, because it takes time to study, and the good way would be to really do a good impact assessment before allowing these kind of activities. But because there's much more pressure from the general society of getting those minerals, it's going to happen, even if we know that it's going to be really bad. So these things are happening faster than the research can cope with, and to provide good advice on how to minimize our impact. So I think that's what worries me more. I mean, in the general framework of things, looking at just plastic pollution on its own, what worries me is just that it will take a lot of time, even with the new policies that are happening now. It's going to take a lot of time before we see something like a clean ocean. Now it's, when I go to the beach with my daughter and we're seeing a lot of plastics in the Port Pin beach, which you've seen, for her, it's normal. So that's what is worrying, that for them it's normal, and to have a clean beach, it's something that is not part of their life. So yeah. And hopefully it's not going to get worse, but I'm not sure.
It's incredible to think about, isn't it? And it's that kind of concept of a shifting baseline. Like our grandparents experienced nature and had a different kind of a view of what a beach looked like and what the ocean looked like compared to, say, us now. And it's very difficult, obviously, to show people what really good can look like when actually we've never experienced it in our generation in places. But I also think your point on deep sea mining is a good one, because, we talked a minute ago about there's a high probability, if not a complete truism, that there's loads of plastic on the seabed, not least because, like so much that goes into the ocean, it ends up as almost like marine snow and debris, and then falls to the seafloor and settles. So churning up the deep sea is quite a scary thought, not least because it's the biggest carbon store on our planet, firstly, which is a little bit dangerous to start muddling with. But secondly, because there's so much that has been settled there and so untouched and undisrupted for not just decades, but hundreds of years. And there's obviously going to be some positive feedback loop, I imagine, in starting to touch that environment and meddle with it. And I think, to your point, it's obviously driven by our shift to new energy sources such as electrics and battery powered systems, which require these resources like cobalt, which can only be found in the deep sea. So there's this real tension between trying to move forward and find alternative solutions and cleaner energy by using batteries as an example, and lithium and cobalt, versus actually protecting what's already a disrupted ecosystem and potentially pushing it to an even further state of disruption, which we just don't know what could cause.
Yeah, and when you think about the minerals, what they're found in these deep ecosystems, these are ecosystems that are really, really fragile. I mean, we don't have any equivalent on land of that much of fragile they are. And these are areas that are really cold. Everything is really slow. Animals grow really slowly. They reproduce maybe, once every 4 or 5 years. It's hard for people to really picture that it's completely different with what we're seeing. It's not like even, like a forest, a tropical forest, which also takes time to establish itself. Things are faster. Over there, it's a completely different pace of time. So if you go there and you just mess a little bit around, it's taking thousands of years to recover to where it was. So that's another thing, that is, this kind of ecosystem cannot, deal with any stress. And like you said, they have a really important service. They're providing a lot of services for ourselves, but also for the regulatory, planet. So if we mess around this large biome, it's going to take a lot of time to recover, and it might impact us in a negative feed loop that we haven't thought about yet. So I wouldn't mess down over there. But as you said, there's a lot of pressure from society to go and exploit those areas. I'm not saying that we cannot exploit them. There's probably a way to do it, but we have to really think about it and really invest in science, long-term science projects to understand how we could probably use them. Not like a 3-year project where you just give a little bit of money for people to go in there, because the more we go, the more we know that we don't know. So it's tricky.
And obviously, probably the most important note to end on, in a way, appreciating that there's a lot of work still to be done, but the way things are looking, we appreciate we've got to do something, we've got to act. What do you feel most positive about? Like, what do you see happening in your respective fields that not necessarily gives you hope, but makes you feel that we're starting to understand things, we're starting to get it, and that we can have a positive impact on the trajectory? Roman?
I think that within the scientific community, it's nice to see that this movement is really moving into the right direction. I mean, people are starting more and more to collaborate and trying to tackle the problem together and join forces, and really trying to setting up projects together also. And that's super nice to see, because most often, I mean, science is a very competitive field, and also the micro nanoplastic field is super competitive. But I think specifically if it's about environmental problems, it's not about being competitive anymore at all, but it's being joining forces and work together and do good work. And this is, for me, from a scientific point of view, really nice to see.
Very good answer. And I think it's interesting, isn't it? Because I think there's nothing in some ways more uniting across industries and across respective fields as an urgent topic, and something as urgent as the very planet we're living on and the very environment that we're relying upon. Chris, what about you? What are you seeing that is super exciting and perhaps motivating?
Yeah, I agree also with Roman's opinion, or Roman's view on there's more and more people are more working together, trying really to solve this. There's a lot of initiatives globally trying to tackle the issue, and you really see people are getting really, enthusiastic about it. So I really hope I'm really seeing there's a change. Now I hope it's going to be fast enough. So yeah, globally I think people are related to that issue. Maybe more than other issues that are probably more important still. But still, it's one thing that is important to get people attention, and I think the public are getting a good image of a good notion of the problem, because it's really graphic. It's really easy for people to relate to. It's something that you can change, yourself. Mm-hmm. So yeah.
And something you can see. I think that's perhaps the, dare I say it, fortuitous thing about something like plastic and ocean pollution in this crudest sense is that you can see it, and you can see it relating to the products that you use and how often you use them and where they end up, in comparison to, say, a much harder conversation to get people involved in, such as climate change, which is always a bit more abstract to everyday life in some senses. But Dr. Christopher Pham and Dr. Roman Lehner, thank you so much for joining me. It's always a pleasure to speak with you both, and we very much look forward to seeing what further research you come out with and how we can learn even more about the impact that our everyday activities and our use of plastic in particular is having on our environment, and particularly our waters.
Thanks a lot.
It was great.
Thank you both. You've been listening to the Clean Sailors podcast. All relevant links to the projects and people we talk to can be found with the podcast link. For all episodes or to get in touch, just visit cleansailors.com. We love to hear from you. We believe that great ideas should be shared, which is why our podcast is free to appear on. So if you've got a project, idea, or topic you think we should be discussing, get in touch. In the meantime, thank you for listening and see you for the next episode.